Building on the successful introduction of the Solidedge electrical design tools into the Solidedge product portfolio, the latest release of Solidedge sees the electrical products go from strength to strength, providing best-in-class solutions to a wide range of industries. Solidedge wiring and harness design and Solidedge electrical routing benefits from great new features and enhanced user workflows to help drive efficiencies and increase productivity. Both Solidedge wiring and harness design are underpinned with an electrical database and parts management system. This provides a central location to organize and look up electrical and harness parts information. The parts and symbols library has seen a significant increase in content both in the form of additional manufacturer standard parts from the likes of Siemens, ABB, Schematics and Schneider to name a few, and also additional support for new device types such as P, M and Y components, which expands the content available to users and improves productivity and reduces errors. Additional support has been added to the ANSI standard with the introduction of ladder diagram schematics. Here we can see a schematic that has been almost completed. The device naming is based on the ladder position, conforming to the ANSI naming convention. Ladder diagram naming is now achievable via user-defined border zones that drive the naming. The ability to control behavior via zonal areas of a product or a system are useful in applications such as industrial machinery design and panel layouts. We need to add an additional pilot light to the schematic. We have the option to insert from the symbol library. The different library standards available to us can be explored, where we can scroll through the relevant subcategories to locate the symbol we require. Alternatively, we can use the filter bar to help refine our selection and save the user time. If a specific manufacturer's part is to be used, we can search for this in the parts database. Either a full search or partial search can be performed to locate the part required. As the symbol we want to use is already on the screen, we'll reuse existing data with a copy and paste action. A new enhancement sees the graphics become a ghost, which moves with the mouse. This provides better guidance for the user and increased accuracy on placement. The numbering on the pilot light is automatically assigned to represent where it has been placed on the ladder. As the device is moved around the design, the name of the device updates accordingly. To finish off the design, we need to add a wire. A simple selection of the pin on one component, and then the pin selection on the pilot light sees the wire generated. The wire needs renaming, which is a simple task. However, to avoid multiple wires being called the same name, the intelligent DRCs, or design rule checks, that are a standard feature of wire and harness design, prevent this from happening and avoiding any duplication errors. The wire needs some additional properties. Users can quickly assign the correct color, material, and spec of the wire. This information will automatically be made available in any tables reports that are generated. Now that the design is complete, the electrical engineer wishes to collaborate on the project with the mechanical engineering colleague. Using connector mode to link Solidedge wiring design and Solidedge electrical routing makes for a seamless workflow between the 2D electrical schematics being used to design the wiring and the 3D mechanical assembly. The unique nature of the connected systems allows for the exchange of data without the need for file imports or exports. Here we can see the machine that the electrical schematic belongs to. The electrical panel is partially completed with both 3D electrical components and some of the wiring. Some additional electrical components and wiring need synchronizing from the wiring design application into the mechanical assembly. Activating the electrical routing environment inside Solidedge allows the mechanical engineer to establish a connection to Solidedge wiring design. The electrical engineer also connects, completing the link between the different machines, creating an ECAD and NCAD bridged environment. A useful feature of connector mode, cross-select, allows for the bi-directional highlighting of any components or wires associated to the electrical schematic. This capability provides the electrical and mechanical engineers advanced precision if discussing a project from separate locations. The 24-volt DC-1 wire hasn't yet been synchronized from the schematic to the mechanical panel layout. In order to do this, in wiring design, the electrical engineer creates a filter group for the information that needs to be synchronized. With a quick click of the bridge out button, a report is produced to clarify what components and wires have been transferred to the mechanical environment. Back in Solidedge, the mechanical engineer gets a notification that new data is available to be synchronized into the mechanical assembly. Clicking on Accept launches the harness import wizard. The CB11 component has automatically been identified within the Assign Component stage. In the Assign Terminals dialog, the information detailing the from and to information for the wires is automatically populated for wire 24-volt DC17 and wire 16. Clicking on Finish exits the wizard and adds two wires to the assembly, going from the PLC to the circuit breaker and circuit breaker to the terminal strip. A quick selection of the new wires highlights them across both applications. The final thing for the mechanical engineer to do is route the new wires around the assembly in the desired manner. Editing the paths of the wires allows for precision tangency control to be applied. The wire running from the circuit breaker to the terminal strip needs to be routed around the cable tray. Simply using Solidedge wire routing tools, we can select a predefined path within the cable tray, and selecting the wire that needs routing is all that's required, and Solidedge takes care of all the rest. During the synchronization, all of the properties for the components and wires were transferred over. Looking at the properties of wire 16, we can see the color, cross-sectional area, and the wire length that has now been calculated as it's been routed in the 3D assembly. The electrical engineer needs to amend the schematics and change the color of wire 16 from blue to black. A quick bridge out and the modification is quickly transferred back to the mechanical assembly. The mechanical engineer receives the update and confirms the import process. As the only change was for the color of wire 16, there is no routing of wires required, but just the observation that the color change has been pulled through. To give a more accurate representation within the assembly, the wires can be converted from a single thickness wire to a physical conductor that uses the cross-sectional area assigned to the wire. Back in wiring design, the electrical engineer needs to create some additional content to share with other colleagues. A wireless report is required, and this can be selected from the standards reports included within Solidedge wiring design. All of the information for the wires is automatically populated, including wire name, color, spec, material, and the from and to information. Customized reports can also be generated by users if specific information needs reporting on. Finally, the schematic diagram needs saving out. Support for DXF format has been added in this latest release. The electrical engineer has the option to save a single diagram, a selection of diagrams, the complete design folder, or the entire project. Taking a look at an alternative example, we have the lighting on the roof of a bulldozer tractor cab. A harness has been created and routed around the assembly for the side and rear lights. A completed harness manufacturing drawing needs to be generated before this harness can go into production. With connector mode still established, we can bridge the harness data in electrical routing through to Solidedge harness design to generate the manufacturing detail. If connector mode isn't established, there is the ability to save the ECAD data out from Solidedge electrical routing, and this can then be opened up in the harness design environment. But as we've already got the connected mode, we'll use the seamless integration to transfer the data. The mechanical and electrical engineers will still have the ability to cross-select and highlight any harness bundles or components that need to be discussed, removing any ambiguity in the design. Inside Solidedge harness design, the electrical engineer needs to create or open an existing harness drawing to be able to bridge through the harness data. From the workflow menu, the bridging command can be activated. The user has options that can be changed depending on the exact scenario, from replacing or updating data in the harness drawing to how the harness is flattened. In the bridge options, further settings can also be changed, such as whether name and part number are imported, and the change policy controls as well. Once the user is happy with the settings, clicking on import will start the bridging process. A report confirming the transaction is presented on completion. The imported harness can be scaled or non-scaled, subject to requirement. We can see the connectors and bundles have been imported with cavity tables automatically populated. The overall bundle lengths are populated on the drawings, along with the positional lengths for the grommet and clip components that have been bridged in from the Solidedge electrical routing. Had the additional hardware detail not already been assigned in the 3D mechanical CAD environment, then the electrical engineer could add the additional hardware by using the many tools available from adding clips, grommets, ring terminals, and different types of insulation. We need to add some insulation to the bottom bundle. This is a simple task requiring a couple of clicks. After selecting the bundle, the user has the option of defining the type of insulation required, with the option including fixed tube to overlap tape to spiral tape. A harness wire list is automatically placed on the drawing, but other reports can be generated for harness connector lists, splice reports, or complete bill of materials should they be required. So as we've seen, Solidedge electrical design software modules cover all your needs for designing electrical systems and manufacturing wire harnesses. This will enhance your time to market, enhance your product quality, and greatly improve your profitability. With Solidedge electrical design, you get your design right on the first try.